Okay, so now we're going to talk about a category of infinite series called p-series. So we said let p greater than 0 be a real number. Be a real number. Then we look at the infinite series defined to be 1 over k to the p, where p is a power. Well, it turns out that this thing will converge if p is greater than 1. If p is greater than 1. Right? Even if it was like 1.1 power, integral of p to like the 1.1, right? It will actually converge because you would rewrite that as k to the minus p power. And then if you used your k, I guess it would be x to the minus p. And then if you did the integral test, you'd add 1 to it, right? And as long as p is bigger than 1, minus p plus 1 will be negative. And so minus p plus 1 will still be negative as long as p is greater than 1. And if it's negative, that means it's going to go into the bottom. And it'll be 1 over x to the p minus 1 power. X to the p minus 1 power, as long as p is greater than 1. And of course, every one of those things, when you do the limit, will go to 0. But if p is not greater than 1, right, using my formula again, integral x to the minus p, well, we would add 1 to it, right? We would add 1 to it. And if p is less than 1 or equal to 1, all right, if p is equal to 1, then you'll just have 1 over x, which will be ln, and we know that integral diverges. If p is less than 1, then minus p plus 1 will be greater than 0. And so you'll end up having an x to the minus p plus 1. But where minus p plus 1 is greater than 0, then that whole thing is going to go to infinity. Okay, so that's kind of a little of the reason for why this works. So we say p-series, 1 over k to the p, converges if p is greater than 1, and then it diverges if p is less than or equal to 1. Okay. Of course, p-series is only, again, for positive powers, because if p was a negative power, then you'd move it to the top, and now you have something that the underlying sequence will itself diverge. So, of course, the infinite series would diverge. So that's why we limit it to positive powers only. And again, p-series will converge if p is greater than 1, and it diverges if p is less than or equal to 1. Okay, so let's look at a couple of examples. P-series is nice because it gives us a quick way to be able to judge, what's happening with our infinite series in a lot of circumstances. So let's consider the infinite series as k goes from 1 to infinity of 1 over the cube root of k. Okay, so that's p-series, 1 over k to the 1/3 power. So since p would be 1/3, that's less than 1, we know our series is going to diverge. On the other hand, if we have the series as k goes from 1 to infinity, 1 over k to the 3rd, well then p is equal to 3 there, and the series will converge. One last example here with p-series. Let's look at the sum. They don't have to start at 1. They can start other places. K equals 4 to infinity of 1 over k minus 2 quantity squared. Now that's not a simple k, but it's essentially, if you're plugging in the numbers 4, we can actually shift things backwards. All right, so this is still just 1 over stuff squared. And so this is p equals 2. And so therefore this thing is going to converge as well. Right? This thing's going to converge as well. Okay, so those are some examples of what we call P-series. P-series.